Today we are going to have another video where we discuss exponential functions again. We're going to do more about exponential growth and decay. In our last video, we have discussed the graphs of exponential functions. What does it mean to have an exponential growth or decay? We discussed the domain and the range of exponential functions and how to find the y-intercept. Today we will only talk about word problems. We will see 4 different problems. They are all solved by the same rule that represent exponential functions. So let's start with the first one. Now before we go through the problems, let's first of all look at the rule we have here. This rule indicates that for any amount after t period of time, a of t, now a of t is the name of the function. So the amount of any amount after t time is equal to a, and a here is the initial amount, multiplied by 1 plus r, and 1 plus r is the growth factor, which is equal to the rate plus 1 to the power of t, which is the period of time. Remember when we discussed exponential functions, we said that y is equal to a b to the power of x, where y was the value of the output. So if I want to write that as a function, so I named that function as a, so a of t is equal to a here, the initial amount. If you remember when we were graphing, a was the y-intercept. The y-intercept is the amount when x is equal to 0, so it is the initial amount. So a of t equals to a, the initial amount, which is the y-intercept in case I have a graph, multiplied by 1 plus r. So I can say without a doubt here that 1 plus r is equal b. b was the growth factor or decay factor, while r here is the rate of the growth or the rate of the decay. Okay, we had to the power of x when x was the input. Here, because the input is t, which is time, then it's going to be to the power of t. So basically what we're doing is we are changing the parent function that we have been working with into a rule that we can use in any word problem. So let's see how we're going to apply using that rule. This is our first question here. It says, suppose you invest $500 in a saving account that pays 3.5% annual interest. How much will the account will be in the account after 5 years? Now I can say here without a doubt that the $500 represents the initial amount. This is the amount you have started investing, okay? And 3.5 here is the rate. Now the rate is usually written as a percent, which is 3.5 over 100. You can change it into a decimal, which is 0.035. And I was told that how much will be in the account after 5 years, then I know that t is equal to 5. I'm going to use what's given and substitute in the formula we just agreed on. So a of t is equal to a, which is 500, multiplied by 1 plus 0.035, and that is to the power of t. And in case t is equal to 5, then I can write 5 here. Just plug this into your calculator the way it is, and you will find your answer to be $593.84. Make sure when you find your answer and it's money that you round to 2 decimal places, because you only have 100 cents in a dollar. So we saw now how I'm going to use this rule if I am talking about investment and bank accounts. Now let's look at our second question. We're going to use the same rule again. In this question here, it says the population of a certain animal species decreases. Take care, if it decreases, then the change is negative because it's going to decrease at a rate of 5%. So I have r here equal to 0.05 by dividing by 100 per year. You have counted 80 of the animals in the habitat you are studying. So this is your initial amount. This is a here. Okay, write a function that models the change in the animal population. How many animals will be left 3 years later? So you know that time is equal to 3. So our first question was about investing money. This question here is about population. Both of them are represented by exponential functions. So let's see how we're going to work here. Again, same rule. A of t is equal to a 1 plus r to the power of t. Now a of t is going to be a of 3 because I want to know after 3 years how much is it. The initial amount is 80. I have 1. Instead of adding, I'm going to subtract because it decreases, 0.05, and that's to the power of 3. Now just plug this into your calculator normally. You will get 68.59. This is how many animals will be left. However, when you write your answer, it cannot be a decimal because it's a number of animals. Then you're going to say about 68 animals. Of course, we're going to go like you don't round. We don't round. We take the minimum because it's number of animals. I can't say 69 because I know they are going to be less than 69. It's number of animals. We don't round. We take the least number. Okay? So we had a question about investing money, another question about population. Now let's look at our third question. Now this question here is manufacturing. It says the value of an industrial machine has a decay factor of 0.75. Take care, this is not the rate. This is the decay factor, which is B. So this is the value of B. This is not the rate. I'm not going to add to 1. Okay, per year. How do I know? Because they said it's a factor. As we said, B is the decay factor while R is the rate. So make sure you differentiate between them before you solve. Okay, it's 0.75 and they already gave it to you as a decimal, so no need to do anything else. Only if it's a percent, we divide by 100 per year. After 6 years, so this is the time, equal to 6, the machine is worth 7,500. Okay, so if we read that again, we will see that we don't have an initial amount. They didn't give us how much it was when they started. They gave us how much it is after 6 years. It's worth after 6 years. So what are the original values? So what is missing is A here. So again, I have the same formula, A of t equals A multiplied by not 1 plus R, this time it's B to the power of t. Okay, now I know that after 6 years the amount is going to be 7,500. A is the unknown. I know B to be equal to 0.75, it's given, and I know the time to be equal to 6. Now to find the value of A, you are simply going to divide both sides by 0.75 to the power of 6. Just use your calculator. Then you'll get that the value of A is equal to 42,139, and when you round, 0.92, and that's dollars, or 4,200. Sorry, $42,140. Of course, as you can see, the initial amount here was more than the amount you have now. Like 42,000 is way more than 7,500. Why? Because we had a decay factor. So we had a big number that depreciated or decreased by time. The question here says, before a basketball game, a referee noticed that the ball seemed underinflated, as she dropped it from 6 feet and measured the first bounce at 36 inches and the second bounce at 18 inches. Write an exponential function to model the height of the ball. So now I'm supposed to model the height of the ball, and I am thinking about how many times it's going to bounce. We have first bounce and second bounce, so again it's how many times this time, not the time. I need the initial amount. Apparently I do have it here, which is A. Okay, now I need a rate, which I don't have, so I'm supposed to look for the rate. Now this is the first thing I need to do, and I need time. Apparently in the second part we know how many times. Okay, so the missing thing that I'm looking for is the rate. Now what will help me to find the rate? I have the first height where it bounced, which was 36 inches, and the second height. So to model this question now, she dropped the ball from 6 feet, right? Then the ball on the floor here, it bounced once, and here the height was 36 inches, right? Then it bounced again, and here the height was 18 inches, and I want to know how high will the ball be on the fifth bounce. So it's going to continue bouncing, and I want to know how much will it be on the fifth bounce. Now I'm going to use these two to find the rate. How do we find the rate? Now the rate is usually found by y2, the second height, minus y1, the first height, over y1. Now this is a rate of change. If you remember, when we used to find the percent of change, you were supposed to subtract new amount minus original amount divided by original amount, then you multiply by 100 because it's a percent of change. Now it's not a percent, it's a rate, so I don't need to multiply by 100, but I am going to use the new amount minus the original amount divided by the original. Now the new amount is 18, original was 36, like the second bounce was 18, the first one was 36, and that's divided by 36. Your answer is going to be negative half. So I used this rule to find the rate. Now I can substitute in the function I have. I need the height, okay, and my original amount was 6 feet when she dropped the ball the first time. Take care that both of these are in inches, so you need this 6 feet also to be in inches. Like all the values in the equation have to be in the same unit. So I'm going to multiply by 12, so my answer here is 72 inches. So my initial amount is going to be 72 multiplied by 1 minus half to the power of, well, if I just want to write the function, I'm going to write t. If I want to find the value, how high will it be after the fifth bounce, then I'm going to substitute for t equal 5. Okay, t here is not the time, it's how many times you are going to bounce the ball. So it's 72 multiplied by half to the power of 5, and my answer here is going to be 2.25 inches is the height after the fifth bounce. So now we have seen 4 different questions. One of them about money investment, one of them was about population, and we had also one where we discussed the decay of when we were manufacturing, of the value, depreciating of the value of a machine, and this last question is about sports. All of them represents exponential functions. Sometimes it's a decay and sometimes it's a growth. We have discussed the rule that we have used at all times. We know that the rate is equal to y2 minus y1 over y1 in case it's not given. We know that the growth factor or the decay factor in case it's not given is 1 plus the rate. And we have by now solved as many questions to make it easy for you to solve in the future. I hope this has been helpful, and thank you so much for watching.